Hey everyone, in this video, I'm going to be going over the legal problem, longest substring without repeating characters. So first, let's do the question. Given a string S, find the length of the longest substring without repeating characters. And just to clarify, a substring must be a contiguous part of the string. So for example, in example 1, ABCA is a substring, but CBCB isn't a substring because it skips over this letter. And down here, it says that S, the string, consists of English letters, digits, symbols, and spaces. So how I'm going to solve this issue is by using a two-pointer solution. So I'm going to have 2 pointers, a left and a right. And I'm also going to have a hash map to store the letters as well as the last index. And what I mean by last index is if we see a duplicate letter, we're going to update the index to be the new index. And while there are no duplicate letters, we only move the right pointer. And once we see a duplicate letter, we move the left pointer to be 1 plus the index of the previous occurrence of the letter, only if the index of the previous occurrence is greater than or equal to L, the current value of the left pointer. So let me go over an example. So here, we have a string ABCC, and at the beginning, our left and right pointers are initialized to 0, and this is a hash map seen is empty, and max length is 0. So in the first iteration, the letter we see is A, and so because we haven't seen A before, we just simply add it to the hash map as well as with its index. So that's why you see this A0 entry here. And max length is 1 because right minus left plus 1 is 1. And our left pointer doesn't move, but our right pointer moves 1. So now it's a 1. Iteration 2. The letter we have is B. Again, B hasn't been seen before, so we add it to the hash map. So now our hash map has 2 entries. A with index 0 and B with index 1. And our max length value increases to 2 because 1 minus 0 plus 1 is 2, and it's bigger than the previous value of max length. Our left pointer stays the same, but the right pointer moves again, so it's at 2. On the third iteration, we see another new letter, C. And just like before, we simply add it to the hash map. Our max length also updates to 3 because 2 minus 0 plus 1 is 3. And once again, because this is a new letter, our left pointer doesn't change, but right pointer changes to 3. Now, with iteration 4, we see a duplicate letter. The letter that we're currently at is C, but we've seen a C before. So what we do is we find the last index of where C was. So in this case, the last index of C is 2, and we move the left pointer to be 1 plus that. If we simply update the left pointer to be the index of the last occurrence, you still have a duplicate letter, right? Like you still have duplicate letter in your substring. So we want left to be 1 plus the index of the previous index. And another thing is that because the index of the previous occurrence of C is 2, and our value of L is 0, it's safe to move. So now left is 3 and right is 3. And in our scene hash map, we update the index value of C to be 3. However, our max length value doesn't change. It's still 3. So that was an example where you saw like us update the left pointer. But suppose now we have a new letter called A. So if we were to do this, right, and we go to iteration 5, the char we see is A. But here's the thing, right? Look where the previous index of A was. It's at index 0. Our left pointer is at index 3, but the previous index of A was at 0. So if we were to update the left pointer, then it will become 1. But this doesn't make sense because if I were to draw this out, if we have something like this, right? There is this duplicate letters in the substring. So that's why we only update the left pointer if the index of the previous occurrence of the duplicate letter is greater or equal to the current value of the left pointer. If it's uh smaller than the current value of the left pointer, we don't update it because we don't want to go back in S. So now that's it. Let me code this up. So I'm gonna have a hash map called chars, a max length variable to store the maximum length where we don't have any repeating characters. It's going to be initialized to 0 and a left pointer. So we don't need explicit right pointer because it's going to be using a for loop, and this for loop is going to be so this I in a for loop, that's going to be a right pointer. So let me just note this. I is the right pointer. So we get the char of the we get the letter of the current index, and we check. So if char is in chars, which is a hash map, and the previous index is greater or equal to the left pointer, left, then we update left to become a 1 plus this value. Because like I mentioned before, right? If we simply set left to the previous index, so it should be the index of the previous occurrence of the letter, you will still get duplicate letters in the substring. And if the index of the previous letter is smaller than left, meaning that the letter is left to the letter that left is at, then we're gonna move back in the string, which we also don't want. And here we're gonna update sorry. We're either going to update or create a new entry in the hash map with the key being the letter and the value being the index. And finally we update max length. So again, it's going to be the max between itself and the length of the pointers. So in this case, remember I is the right pointer, so it'll be I minus f plus 1. And finally, we return max length. Oops. So let me do a quick test run to make sure I didn't mess anything up. Okay, looks good. And let me submit it. Yep, you can see that this is a valid solution. And it's a pretty efficient solution too. Because we're looping through the string once, this is at O of n time complexity. Thank you all for watching.